आज हामी पढ्न गइरहेका छौँ होइन डिफरेन्सियल इक्वेसनको एउटा एकदमै इम्पोर्टेन्ट एउटा टपिक छ होइन त्यो भनेको कुन भन्दा हाम्रो छ लिनियर इक्वेसन भन्ने छ। लिनियर इक्वेसन धेरै धेरै किसिमका हुन्छन्। एउटा हुन्छ हाम्रो अर्डिनरी हुन्छ, अर्को भनेको सेकेन्ड डिग्रीको हुन्छ। जुन आज पढ्ने भनेको हामीले लिनियर अर्डिनरीवाला हो। अनि यसको हामीले जान्नुपर्ने कुरा भने यसमा के छ भन्दा एउटामा डेफिनेसन छ, अर्कोमा यसको सोलुसन जान्नुपर्ने हुन्छ हामीले, अनि अर्को यसको गर्नुपर्ने स्टेप्सहरू हुन्छन् हामीसँग। अनि यसपछि हामीले केही इक्जाम्पलहरू गर्नुपर्छ। अब हामी उसमा जाम डेफिनेसन जाम है। अनि यो लिनियर अर्डिनरी डिफरेन्सियल इक्वेसनले के भन्न खोजेको भन्दा खासमा यसको एउटा हाम्रो फर्म हुन्छ जस्तै द डिफरेन्सियल इक्वेसन in the form of dy by dx plus py is equal to q। यो भनेको एउटा फर्म हो। अनि यसमा वेयर p and q आर द फङ्सन हुन्, यिनीहरू आर द फङ्सन अफ एक्स हुन्छ जहिले पनि, किनभने हाम्रो डेरिभेटिभ विथ रेस्पेक्ट टु हाम्रो एक्समा छ। त्यही भएर पी एन्ड क्यू भनेको हाम्रो फङ्सन हुन् अफ एक्स। अरू यो कन्सटेन्ट पनि हुन सक्छन्। अनि यदि हाम्रो यसमा जुन हाम्रो फङ्सन छ वाइ, यदि यो वाइको टर्ममा यदि क्यू छ भने त्यसलाई हामीले अर्को इक्वेसन गर्न सकिन्छ, त्यसलाई भन्छ बर्नौली इक्वेसन भन्छ। अनि त्यो हामीले पछि गरौँलाई। यसको यो भनेको हाम्रो के भयो, डेफिनेसन भइहाल्यो। अनि यसपछि हाम्रो सोलुसन जान्नुपर्ने हुन्छ। सोलुसनले के भन्छ भन्दा हाम्रो सोलुसन फर द लिनियर अर्डिनरी डिफरेन्सियल इक्वेसनले के भन्छ भन्दा वाइ इन्टु इन्टिग्रेसन फ्याक्टर इज इक्वल टु एन्टिडेरिभेटिभ क्यू भनेको जुन हाम्रो फङ्सन अफ एक्स अथवा कन्सटेन्ट त्यो इन्टु इन्टिग्रेसन फ्याक्टरको डिएक्स भन्छ। यो भनेको हाम्रो डाइरेक्ट सोलुसन हो। यसबाट हामीले सजिलै हामीले कुनै पनि एउटा हाम्रो प्रब्लमहरू सल्भ गर्न सकिन्छ। अनि यसपछि हामीले गर्नुपर्ने स्टेपमा जानुपर्ने हुन्छ। हामी स्टेप भनेको हाम्रो अब यसमा बुझ्न सकिन्छ कि कसरी गर्ने, हामीले सोलुसन कसरी निकाल्ने भन्ने कुराहरू। अब हामीले बुझिसक्यो, यसको डेफिनेसन बुझिसक्यो। डेफिनेसन बुझिसकेपछि हामीले सोलुसन कसरी निकाल्न सकिने बुझिसक्यो। सोलुसन हाम्रो के छ यहाँ हेर्न सक्नुहुन्छ, वाइ इन्टु इन्टिग्रेसन फ्याक्टर इज इक्वल टु एन्टिडेरिभेटिभ अफ क्यू इन्टु इन्टिग्रेसन फ्याक्टर छ। अनि यसमा हामी जान्नुपर्ने भनेको कुरा के छ भन्दा इन्टिग्रेसन फ्याक्टर छ। पहिला हामीले के गर्नुपर्छ भन्दा हाम्रो दिएको सोलुसनले हामीले जहिले पनि लिनियर इक्वेसन लानुपर्ने हुन्छ। फर्स्ट स्टेप भनेको हाम्रो के भयो, वी हेभ टु मेक आवर गिभन प्रब्लम अथवा क्वेसन इन्टु लिनियर फर्म। त्यो लिनियर फर्म भनेको कस्तो भन्दा हामीले डिवाई बाई डिएक्स प्लस पिवाई इज इक्वल टु क्यूमा लानुपर्ने हुन्छ। अनि यसपछि गर्नुपर्ने भनेको के भन्दा अब हामीले छुटाउनु पर्ने हुन्छ हामीले पिएन क्यूको लागि। पिएन क्यूलाई चिन्नुपर्ने हुन्छ। त्यो चिनिसकेपछि हामीले के गर्नुपर्छ भन्दा हाम्रो इन्टिग्रेसन फ्याक्टर पत्ता लगाउनु पर्ने हुन्छ। इन्टिग्रेसन फ्याक्टर आइएफ के भन्छ भन्दा हाम्रो ई पावर एन्टिडेरिभेटिभ पी डिएक्स भनेको हुन्छ हामीलाई। अनि यो पी भनेको के भन्दा यो फङ्सन अफ एक्स हुन्छ अथवा यो कन्सटेन्ट हो जुन हामीले लिनियर फर्ममा लैसकेपछि त्यहाँबाट हामीले कम्पेयर गरेर लेख्न सकिन्छ। अनि यो पनि हामीले निकालिसकेपछि अब यसपछि हामीले गर्ने स्टेप भनेको के भन्दा हाम्रो डाइरेक्ट सोलुसनमा गएको हुन्छ हाम्रो। अनि हामी यसपछि जाने भनेको सोलुसनमा गइहाल्नुपर्ने हुन्छ। त्यो भनेको के भइहाल्यो, वाइ इन्टु इन्टिग्रेसन फ्याक्टर इज इक्वल टु एन्टिडेरिभेटिभ अफ क्यू इन्टु इन्टिग्रेसन फ्याक्टरको डिएक्स गर्नुपर्ने हुन्छ। अब हामीले स्टेप पनि हेरिसक्यो। अब हामी कुनै एउटा इक्जाम्पल गरिहालौँ अनि हामी क्लियर भइन्छ हाम्रो कन्सेप्ट। पहिला सिम्पल इक्जाम्पल गरिहालौँ है त। जस्तै उसलाई सरल बनिन्छ हैन dy by dx minus y upon x is equal to x अब हामीले स्टेपमा हेरिसकेका छौं पहिला हामीले के गर्ने हो हामीले पहिला लिनियर फर्मुला हेर्नुपर्ने हुन्छ हैन अब यहाँ हेर्न सक्नुहुन्छ अब हजुरले dy by dx minus y upon x is equal to x भनेको पहिले हाम्रो केमा छ लिनियर फर्ममा छ किनभने सोलुसन गिवन dy is equal to dx minus यो 1 upon x भनेको छ 1 upon x भनेको के भयो हाम्रो यो फंक्सन अफ x को रुपमा छ किनभने हाम्रो विथ रेस्पेक्ट टु x मा छ कि त यो कन्स्टेन्ट हुनु पर्ने त कन्स्टेन्ट नभएको नि ठीक छ यो के भएन इन्टु y छ त्यो भएको फंक्सनको भ्यालु भइहाल्यो इज इक्वल टु x अब कम्पेयरिङ गर्न बेलाई सेकेन्डमा के गर्ने होला हामीले कम्पेयर गरेर p र q को भ्यालु निकाल्नु पर्ने हुन्छ comparing given question with linear ordinary differential equation and that is dy by dx minus py is equal to q. From here we can easily compare the given question with the linear ordinary differential equation. Then we can find that p is equal to minus 1 upon x and then q is equal to x. Simple. After that we have to find our integration factor, that is integration factor integrating factor if is equal to e to power antiderivative of p dx. Here p is equal to minus 1 upon x dx after taking minus side 1 upon x dx and antiderivative of 1 upon x is log x log x and after putting the minus in upside we can find is equal to log that is minus 1 here and then we can put that minus 1 here power because we have to know that a into log b छ भने हामीले यसलाई के गर्न सकिन्छ भन्दा log b को पावर a गर्न सकिन्छ के यहाँ माइनस छ भने यहाँ माइनस भइहाल्यो नि त्यसरी त्यो भएर माइनस भयो अनि यो गरिसकेपछि के हुन्छ always remember that log always cancel the exponential, that is exponential cancel the log and then remaining is x minus 1, that is 1 upon x. Yeah, from here we can find that integration factor is 1 upon x. After that we have to go to our step 4, that is solution part. In solution we explain that our solution is y into integration factor is equal to antiderivative of q into integration factor dx. Here our given function is y, that is similar y, and the integration factor is 1 upon x. From here and integration factor q and our given q which we find after the comparing with the given question, that is q is equal to x. We have to put here x into 1 upon x for dx. Okay, and then here y upon x and then here x is cancelled, that is remaining 1 for dx. Y upon x, okay, y upon x is equal to 1 co-antiderivative x, okay, x plus c. Simple. From here we can find that y is equal to x square plus cx, where c is the our term which come from the antiderivative, and y is equal to x square plus cx, which is our required equation, which is required solution. From here we can easily solve our one problem which is given to the linear equation. And then one important note is that we some questions are very complex, that is given function are two types, that is in terms of q there may come the second degree of y. For that just like the question we can assume that dy by dx is dy by dx plus py is equal to q y to power n. These types of complex equation can be arise. So how can we solve that? We can solve that by using the Bernoulli equation. What Bernoulli equation say that? That's the definition. Bernoulli equation. Here we can find that first step definition. The differential equation in the form of dy by dx plus py is equal to q to power y power n. Here if we compare with this with the linear ordinary differential equation, and there is q always be the constant or the function of x, because x is the main factor which derivates the y function. That's why here you can find that in terms of q there is common the y to power n. This makes the equation more complex, and if we want to solve this using the linear equation, then we have to go with Bernoulli equation. And how can you solve that? Let's do one short question. The differential equation on the form of dy by dx plus py is equal to q to power y to power n, which is reducible into linear equation in new variable. This definition want to say that these types of complex equation if come, then we can do this with linear equation, but what we have to do, or we have to make one new variable, that is y to power n. Here is you can find for this we have to change the y as a new variable. To clear for the easy clearation, we can do one example. Let's go. Like the solution of the complex one equation, solve dy by dx plus y, here y is equal to here q term n y to power something like we can assume that square. If we compare this with the linear equation, here is similar, dy by dx similar, and plus ठिक छ, and q and y यो पनि ठिक छ हामीसँग, and is equal to गरेर माइनस x सम्म पनि ठिक छ, हाम्रो यो q मा हामीले कम्पेयर गर्न सकियो. तर हाम्रो एउटा यहाँ के आएको छ, हाम्रो फंक्सन फेरि रिपिट भएर यो सेकेन्ड डिग्रीमा आइरहेछ. हजुर हेर्न सक्नुहुन्छ. यो आइसकेपछि हामीले के गर्नुपर्छ भन्दा यसलाई कुनै एउटा नयाँ भेरिएबल यसलाई एज्युम गरेर हामीले यसलाई फेरि लिनियर इक्वेसनमा लगाएर हामीले यसलाई सल्भ गर्न सकिन्छ. कसरी गर्ने त अब हामी हेरौँ है त. अब पहिला हामीले यसलाई लानुपर्ने हुन्छ. अब पहिला के गर्नुपर्छ, हामीले त के हुनुपर्छ, हाम्रो q कोटा मात्र हुनुपर्ने हुन्छ. यता कुनै पनि एउटा फंक्सन एसोसिएट भएर आउनु त हुँदैन. हामीले कुरा थाहा छ लिनियरमा. त्यही भएर हामीले के गरौँ भन्दा त्यो y स्क्वायर छ नि, पहिला यसले यतातिर ल्यायो हामीलाई. के हुन्छ हेरौँ है त. 1/y स्क्वायर dy by dx plus 1/y, because y cancel one time and then remaining is 1/y. Okay, is equal to minus x remaining. Yeah. To make this equation into the linear form, what we have to do? Yeah, you can see that dy by dx, this must be the single term. Here you come the 1 upon y square, this will be changed. So we can assume 1 upon y is equal to something variable, like we can do b. Okay, let's this is let गरियो 1 upon y is equal to b गरियो हामीले हैन. अब यो गरिसकेपछि हामीले यहाँ हेर्न सकौं हेर्यो भने के हुन्छ यहाँ हेरौँ त 1 upon y को गरिसक्यो भनेपछि 1 upon y is equal to b गरिसकेपछि के भयो यहाँ b को b भनेको स्क्वायर भइहाल्यो यहाँ इन्टु d अनि यहाँ d b भइहाल्छ. अनि यहाँ हेर्न सक्नुहुन्छ b स्क्वायर भइहाल्यो. अनि d b गर्नुपर्ने हुन्छ हामीले, पहिला यसमा गर्नु पर्दैन, पहिला कम्पेयर गरेर लियौँ त dy by dx plus 1 upon 1 को b भइहाल्यो is equal to minus x. From here we can find that, and 1 upon 2 is equal to b, and then or we can do that here is equal to minus even going to पहिला y is equal to minus 1. Yeah, this can this can be do from here. Okay, then by solving this we can find that y to power minus 2 dy by dx is equal to always minus db by dx. Okay, by solving this we can find out this by assuming 1 upon y is equal to b. Yeah, okay, after finding that we can find out our linear equation, that is minus y square dy by dx plus y to power minus 1 is equal to minus x is our given equation. And to make it with new variable we can do y by upon minus 2 is equal to dy is equal to we are given this is that is minus db upon dx. Okay, then plus b because 1 upon y, that is y minus 1 is equal to b by assumption. Yeah. Okay, after that here you can compare that this is a required linear form. Yeah, after solving that we can make that this is a it is in linear form. So comparing with linear form dy अथवा db by dx plus pb is equal to q db upon dx minus b is equal to q, because minus will be compromised here. Okay, we get p is equal to minus 1, q is equal to x. Okay, now our second step and fourth step is similar to the step for the linear differential equation, which we can we have discussed some time ago. Okay, that's why now we have to find the integration factor, that is e to power p dx. Yeah, okay, then here is p is minus 1 dx. If you antiderivative the minus 1, what we can get e to power minus here and 1 is remaining here for your more easier. minus 1 को इंटीग्रेशन कति हुन्छ x हुन्छ x भइहाल्यो. अनि यो भइसकेपछि के हुन्छ हाम्रो e को power minus sign is the required integration factor. Now we have to go to the solution, and we have already discussed that solution of the linear equation is y into integration factor is equal to antiderivative q into integration factor for dx. Yeah, here y is, we have assumed that b, yeah, from here. So this equation is b into integration factor, here is e to power minus x is equal to antiderivative of q. After comparing with the linear equation, we have found that q is equal to x, so x into e to power minus x को antiderivative गर्नु. अब यति गरिसकेपछि हामी गर्न सकिन्छ इजिली, माइनस एक्स भइहाल्छ यो. अब यहाँबाट गर्ने भने यहाँ पछि हाम्रो के बच्यो, एक्स ई को पावर माइनस एक्स को डिएक्स गर्नु पर्यो हामीलाई यहाँ. अब यहाँबाट गर्नुपर्ने हुन्छ हामीले. अब यसो गरिसकेपछि यहाँ के आउँछ भन्दा v e को पावर माइनस एक्स सेम. After doing the integration part, this type, this using the partial integration factor, partial integration, we can easily found that here is the one rule from which we can solve these types of integration factor by using the partial integration derivative integration गरेर. partial integration गरेर हामीले यसलाई सल्भ गर्न सकिन्छ. जस्तै हजुरलाई आउँछ होला यो गर्न पहिलेबाट, त्यही पनि हामीले हेरौँ एउटा. We have the formula that if for the antiderivative of bu type of equation, we have to do first time antiderivative uv, okay, uv dx. First u into antiderivative of v minus b antiderivative of derivative of u and into antiderivative of b. Here is become small को पनि derivative. Yeah, this is our formula for solving. By using this formula, we can easily solve and we can find that these problems give the solution after integration, that is minus e to power minus x bracket 1 plus x, okay, plus c. After doing that, as you know that b is our replace variable, which is new variable, but our equation of our complex solution equation is given in terms of function of y, so that we have to do our solution in terms of y, so that we have to replace our value b with y, that is 1 upon y is equal to b, so b is equal to 1 upon y here, and e to power minus x here, minus e to power minus x bracket 1 plus x plus c. After solving it, we can find that 1 upon y and e power minus x and e power minus x cancel out, and we can find it minus 1 minus x plus c into e to power minus x plus x, okay, because this go to the division and then cancel out, and c upon, and then here is c upon e to power minus x is c power e, and minus minus cancel out, and e to power x, that is similar. Yeah, after finding that, this is our required solution for our complex equation given in terms of linear equation. These types of here you can see that these types of solution, these types of equation can be solved using the Bernoulli equation, which is the similar terms of linear equation form, but it is a more advanced form. From them we can solve the difficult questions. Okay, this was for today. We have found for regulation, we have done linear equation and its first type, linear ordinary differential equation, and in second part is second degree of linear equation, which we can discuss sometime after below. Okay, here is definition, solution, steps. Here. Okay, we have done that. Okay, then bye.